Hello everyone, welcome back to my channel. So in this video, we are going to talk about WebRTC's technology, which is also known as real-time communication technology. So have you ever wondered how real-time communication works within the applications like Zoom, Google Meet, Microsoft Teams? By real-time communication, I mean audio calls, video streamings. Have you ever wondered how that actually works? So answer to your question is WebRTC. By using the WebRTC technology, you can enable this real-time communication within your websites, within your applications, without any intermediary server. So by that, we can have video calling functionality. We can have video streaming functionality in our websites, and we do not need to rely on any other intermediary server. So let's get started with the WebRTC. And first of all, I'm going to explain you guys what WebRTC actually is. How does that work? I'm just kind of repeating myself. So WebRTC, again, short for Web Real-Time Communication. It's a technology that enables audio, video, and even the data transfer directly between browsers or devices. No middlemen at all. The best part is it's natively supported in all modern browsers like Google Chrome, Microsoft Bing, Edge, Firefox, whatever you're going to use. It is compatible with all the modern browsers. So it is a go-to choice for the apps like video conference tools, online gaming platforms. So we're going to need video streaming if we want to build an online gaming platform or online gaming stream platform. So we can use WebRTC in order to implement that. At high level, WebRTC establishes a direct connection between the two devices using something called RTC peer connection. So RTC peer connection is an API which will help us to establish a connection between two devices, or we can say two users. Okay, but to make that happen, we need a little setup. So what do we need to set up? So first of all, our browser obviously needs to capture audio and video streams, and we will be able to do it using the get user media API. Okay, and then peers exchange information like network addresses and connection details through a signaling mechanisms. So let's say user A will have to exchange all the information related to its network to the user B. That means we need a signaling mechanism. We need something which can carry it forward to the users. So finally, once the connection is established, the peers can stream audio, video, or even transfer data directly without relying on any other server. Okay. So now let's understand what the workflow is, how things flow within the WebRTC functionality. So first of all, it's going to do the media capture. So by media capture, again, as I said earlier, we are going to need to record audio streams and video streams using our cameras and microphone. Okay, and the second thing which will come after media capturing, that will be the signaling. So this is where the users are going to exchange SDP. So what is SDP? Session description protocol and network info. So all the things that are going to be needed uh, for network in order to communicate, it is going to exchange it through a signaling server. And then the next thing which will come after that will be ICE candidates. So ICE candidates, again, the full form is interactive connectivity establishment. What this is going to do, it's going to find the best path for connecting to the peers. So there will be multiple paths available, but our network, our signal mechanism will have to go and find out the most efficient path, and that is what ICE candidates are going to do. Okay, and then the last thing is going to be the peer-to-peer communication. Once everything is set up, all we need to do is we need to flow the media stream directly between the devices. Okay, so This was all about the workflow and how WebRTC works. But one more thing we need to take care of while we are building this web streaming applications, and that is the role of stun and turn servers. Okay, so now let's talk about something very crucial. Okay, so a stun server, so what Stern server is going to do, it is going to figure out their public IP address. It is going to figure out the public IP address of the user and navigate through the network address translators. Okay, so yeah, this might sound very complex. Let me explain you in the simpler terms. So what actually is going to happen here? So let's say I'm a user A. Okay, so I'm a user A. I'm on a private network. I'll have some IP address XYZ. Okay, so what we are going to do is that it is going to be behind NAT, right? So it is not going to have a public IP. In order to connect through the other user, sorry, in order to connect with the other user, we will need a public IP, and that is what Stern server is going to do and help us to get the public IP. Okay, so imagine a device asking, "Hey, Stern server, what is my public facing IP?" The Stern server is going to reply, and this info is shared with the other peer to help establish a direct connection. So user A is going to send its private IP to Stern server. Then Stern server is going to give the public IP to user A, and that public IP will be sent to user B with whom we want to connect. Okay, now user B is also going to do the same thing. User B is going to send the private IP to the Stern server, and then once both the users will have their public IPs, then they will be able to connect with each other. Then they will be able to establish a connection. Okay, but we also have some exceptions in this case. So if we go to our colleges, or if we are connected to any corporate Wi-Fi's, we are most probably going to have some restrictions to our network. Okay, and that is where the turn server comes in, right? So it relays all the media and data between the peers. So once so look, if stun servers fail, that means there is some restriction in the network. There is some restriction in the network, and that's why both the users are not able to connect. When that will happen, that is where turn server is going to come into the place. And what that is going to do, it is going to act as a middleman, and it is going to have both the users connected by relaying all the media and data between the peers. Okay, so that is how turn server works. And now let's just look at the last um, thing we need to discuss before we get into the code. That will be a signaling mechanism. So before two peers can communicate, they need a way to exchange connection details. That is where signaling comes in, right? So obviously I'm sharing my network details, I'm sharing my IP and everything, but how that is actually happening, who is carrying all of that information? So WebRTC does not specify how signaling should happen. It's yeah, they actually leave it to the developers. It could be through WebSockets, it could be through socket.io, or we can also do HTTP requests if we want to carry that communication further. In our project, in our code that I'm going to use today, we will use socket.io to handle signaling, because I think that is the easiest implementation when it comes to WebRTC, and it's very important to make it less complex while we're learning. So socket.io we will be using to have the signaling in our application. It will let peers share their offers, answers, and ICE candidates, paving the way for a seamless connection. Okay, and as I mentioned earlier, we're going to use RTC Connect Pure Connection API, which will be responsible for handling the connection between the peers. So do not worry at all if it sounds complex. Once I start coding, once we will get to the coding, I will break it down for you step by step, and it will be very easy to understand. Even in the beginning, if it seems that it's very complicated and I'm not able to catch up, just do not give up. Just just hold on and have a look at the entire code, and eventually you're going to realize how the things work. And once you realize, there is no I think there's no going back, and then you can start uh, developing the applications. So let's get started with the coding now. All right, so now we have understood all the things we needed to understand regarding the WebRTC. So let's dive into the code now. Let's look at the practical aspect of how this works. So before we do anything else, first of all, let's just install all the required libraries. As we discussed, we are going to need Express, Socket, IO, Pure.js. Yeah, I think only these three libraries will be good to run this application. I have all of these already installed, but just to make sure I have it, I'll run the command with you guys. And if you don't have it installed in your system, you can just go and install it. Okay, so I will say npm install express. Okay, npm install socket io and pm, and then we also need to install the pure.js install the pure.js client in order to interact with other users. So we would just need npm install pure.js, and this is going to download all the required packages which will be uh, needed for this implementation. And the last thing we're going to do is we will do npm init -y just to initialize our node.js project. Okay. Okay, so now we have everything set up. Let's start coding in JavaScript first of all. So we're going to create a folder here which will be required to have a specific naming convention. So we're just going to have it named as public, and then inside that we're just going to create a JavaScript, and that is where everything will be residing regarding our video call streaming app. So we are just going to write it here script.js. Okay, perfect. Now let's start implementing each and every functionality one by one. So in this script, we will create a real-time video streaming app using socket.io and pure.js. So let's start with our JavaScript. We begin by connecting to the socket.io server using IO. Okay, so we are just going to write here const socket is equals to IO. Okay, so this establishes a WebSocket connection to our backend, enabling the communication between the clients. Okay, so next thing we'll grab the video grid element from the DOM. This will hold the video streams of all the participants into the room. So we need something to hold the video grid, and we are going to name it as a video grid, and then we can say get element by ID, and then okay, perfect. The next thing we're going to need here will be the pure.js object. So we're just going to define uh, object called myPure, and it is going to include the host and port configuration, which will be responsible for creating a peer-to-peer connection. And it's going to assign a unique ID to each user that is entering our room, basically. Okay, so const my peer is equals to new peer, and then undefined, and our port is going to be 3001. Okay, perfect. So we have our object created, and now the next thing we need to do is we need to create a video element for the local user and mute it to avoid hearing our own audio playback. So right, so this is going to be very crucial. These are all the small things that we need to take care of, that obviously I do not want to hear my own video, so I would prefer it to be mute. uh, right, so let's first of all create a video element which will display my video on the web page. Okay, so it is going to have document dot uh, create element of it, and then we are going to have a video inside, and then I am going to mute my own video by enabling the my video dot muted. Okay, so now the next thing we're going to need is empty object called peers, or we can, you can keep it as a users or peers, it's up to you. It doesn't really matter. So we need this empty object to keep track of active connections with other users in the room, right? So let's write it down here. Const peers is equals to this. Perfect. And then the next thing we're going to do is we will need to define the initialize stream function, which is going to request access to the user's webcam and microphone using the get users media API. So in our introduction, we are already discussed this, that we will be needing the get users media API, which will request basically the access to users webcam and microphone. So let's write that function down here. So it is going to be like initialize stream. Okay, initialize stream, and then inside of that we will define const stream is equals to await navigator dot media devices dot get user media, and inside that we are going to request to access video and audio. Okay, so we are going to keep it as true. Okay, so that is how it is. That is how it should. That is how it should look like, right? So then we're going to add a semicolon here. Okay, and then the next thing uh, we're going to need is we will need to add the user's video stream. Okay, and we can add user. We can call this function add video stream. Um, we will be defining that later on, but first, but for now, just let's call that function. Obviously the parameters of that function is going to be my the user's video element and the stream object. Okay, so we are just going to call add video stream my video stream. Okay, and then we are going to handle the incoming calls. Okay, we are going to define that function as well, okay, later on, but for now we will just declare it. Okay, we'll just call it. So we set up an event listener to handle this, to handle incoming calls. Whenever another user calls, we answer with our local stream using the handle incoming call function. Okay, so what I'm going to do here, I am going to call my peer dot on. So this is basically just a event listener. Just going to pass a call parameter handle incoming call. We will be defining this function later on, so do not worry about that right now. For now, just follow along and try to understand how each and every line of code is working here. Okay, and then when the server notifies us that the new user has joined the room, we need to call one more function, connect to new user, which will be responsible for establishing a connection with them. And if we want to establish the connection with the user, we will be needing the user ID, which will be the unique identifier for us to identify which user we want to connect. And then the other thing will be stream. right? So other thing will be the user's stream that we need to pass in our functions. Okay, so socket.on user connected, and then again we need user ID, and then we are going to call this function that we will be needing. Okay, and after that, once we have established the connection, we just need to uh, write our error statement here, because we initialized this function. We were trying to implement this function using try and catch, uh, try and catch. So we need to make sure we pass the condition for the error as well. So we will write this, and then it's just going to, if it throws the error, we will just receive this message in our we will just receive this message in our web console, that failed to get the local stream, and then it is going to return the error message, sorry, error code or whatever the thing is. Okay, wow, perfect. All right, so I feel like uh, we have all the things set up to go. Now we just need to define these functions that we have declared here. Okay, so we are calling all these functions, and now we need to define each and every function. So first of all, let's define this function connect to new user, how it is going to handle the how it is going to handle new user connections basically. So we're just going to write function connect to new user. Okay, connect to new user, and as we discussed, we are going to need a user ID and stream that we will be passing. Okay, and then we will uh, declare a variable called call, which will be responsible for initiating a call to the new user in the room using mypeer.call. It creates a video element to display the incoming stream. Okay, so I am going to write mypeer.call user ID and stream const video is equals to document dot create element. This element is going to display the user's video. Okay. Now, the next thing we're going to need, when the new user sends their video stream, we need to display it using the add video stream function. Um, and we are going to implement that by using, again, an event listener call.on stream user video stream. Do not worry about that. We will soon define that function as well. Add video stream video user video stream. Okay, and then we're going to define one more event listener that is going to trigger when we will close the call. Basically, when we hang up the call, it is going to remove the video. So this thing will be responsible for that. And we will do it by using video.remove, right? And then after that, we just need to handle call errors in case if there is any. So we're just going to write down here call dot on error console dot error. Okay, perfect. So I'm just going to copy paste this. I had it pasted. It's going to be the same thing for all the functions whenever we are trying to handle the call errors. And then at the very end, we are going to pass this user into our peers um, we are going to pass this user into our peers object. Okay, so that we defined here. Perfect. Now, our next thing is going to be how we can handle the incoming calls. Okay, so yeah, just I'm just kind of repeating myself. We store the call object in the peers dictionary or peers object to manage um, active connections. Okay, so if we want to manage active connections, it is just going to pass that user ID into that peers dictionary. Okay, perfect. Now let's implement this handle incoming call function. Um, Again, it's going to be very straightforward. It's going to answer the calls from other users like before. We will create a video element to display the stream for one more time. Okay. So that function is going to look something like this. So let's define that function handle incoming call stream. Again, same thing, call dot answer. Okay, this is responsible for answering the call, and then we will need to again display the video element. Okay, create element and then video. Okay, and then we need one more event listener which will be looking something like this. Okay, and then we are going to handle user this. Sorry. So once we have defined the handle incoming calls function, we will need to handle user disconnections, and that is going to be our next thing to implement in this code. So when a user disconnects, the server should notify us. The close their connection and clean up the peers dictionary. So that is what we are going to do. We will need some sort of flag from server that hey, that user is disconnected. So you do not have anybody to connect right now in your video stream. Okay. So again, we need user ID because we will need the reference of that user who has hang up the call or potentially removed from the video stream. Okay. So if peers user ID, again, it should it should match the user ID inside our peers dictionary. Okay. So then we need to do close, and then it is going to remove that user from our dictionary so that we do not need to worry about connecting with this. If we will not remove it, if we will not remove this particular user, then our program is just going to constantly think that this user is still available because this user ID is will be there in our dictionary, Peer's dictionary, and that will just uh, lead to some sort of a deadlock because we will not be able to reach anywhere as it will just keep looking for that particular user, and that user is just not available at all at that time. So we need to delete. That is a very important thing. Okay, so now we need to generate an ID for us. So not we, but basically Pure.js is going to generate an ID for us so that we can notify the server that we have joined the room by sending the room ID and our peer ID. So that means a user ID. Okay. So that will be the event listener for one more time. And I think we will need to put a semicolon here. Okay. So let's let's notify our server that we have joined the room. So we will be passing our user ID, and we will be passing our user ID and we'll be passing a user ID and a room ID because we will need to notify the server that we have joined the room. Okay, so we need both of those parameters included in our code. And the last function we need to implement is add video stream function. This is going to be very important to display video streams. It is going to set the stream as a SRC object of video element, and it is going to append it to the grid. Okay, so let's do it. This is going to be last function, add video stream, video stream. Then we need to add an event listener, which will be responsible to load all the metadata. And once it has loaded it, it will be displaying the video. So we need to have this loaded metadata inside, and then we need to call this video.play. Okay, so after that, we will just do video grid dot append child and then video. Okay, so once it has loaded everything into our metadata, it is going to display the video stream, right, by appending it. The last thing we need to do inside this JavaScript file, will be, we need to initialize the web stream that we have created. Okay, so initialize the web stream function that we have created. Okay, and then we do not need this uh, extra bracket. We had the initialize stream function defined here, right? Okay, so basically it just runs around this workflow. First of all, it is going to request the video and audio from the server. Once it has received it, it's going to send it through a signaling mechanism, which will be the peer.js in this case. Now, just keep a note that we discussed about stun servers and turn servers in our explanation. So, just for the sake of simplicity, we have used the peer.js here, and peer.js has the automatic stun servers. So, with the stun server, what is going to happen? It is going to connect it by using the public IP for both of the users. Okay, if you want to implement the turn servers, it's not that complicated. We can implement it, but for now, just to keep everything simple, we are just sticking to the stun servers. Okay, so now we have created a JavaScript here. So just let's review it again. So we have defined a connect to new user function here, which will be responsible for connecting to the new peer. My peer.call, it is going to call this function, and it is going to display the video of the connected peer, and then this function is going to handle the incoming call.answer. We will be able to respond to the incoming calls by using this function, and we need some sort of notification or some sort of flag from the server that user has this connected, because if we will not be able to get the flag from a server, we will just keep looking for the user that is stored in our dictionary, and eventually we will just stuck in a loop. So we need this function so that if this user has hang up a call, then we need to get rid of that user and it will be deleted from our peers direct dictionary. Okay, and then the next thing we need to do, we need to pass the room ID and the user ID. So once we have opened our application into the browser, it's going to generate a room ID for us, and that will be a unique identifier of the space. What do I mean by that? So if two users are there and if they want to be somewhere, they need some sort of central point of meeting, and in this case, it's going to be a room. Okay, so we are going to create a room that the similarly we have room in Discord and Zoom. Yeah, that is the same case here. Okay, and then it's going to add a video stream, and after everything is done, it is going to initialize stream by calling this function that we have implemented above. Okay, perfect. So we have our JavaScript ready. Now we just need to write a template code, which will be our HTML code, and then the server.js code that will be pretty straightforward to implement. So let me open that. Okay, so now we have implemented our script.js. Now I have already included the template code and the server code into my folder. It is not that complicated. It is very straightforward. So I would prefer to not waste the time, and I will just walk through that code instead of writing it line by line. So we will, if you have noticed, we have created a views folder, and in that folder, we are creating a room.ejs file. The reason of using EJS, you can also use HTML. It's not an issue, but the reason of using EJS is because it's called embedded JavaScript and then the file. This file is going to be a template which will enable us to embed the JavaScript directly into the HTML because we are creating the dynamic room IDs and we are creating dynamic usernames. EJS will be the better option rather than using just the uh, classic HTML. For example, when a user joins a room, server sends data like the room ID or the user info to the room.ejs template, which dynamically embeds that data into the HTML. So EJS works smoothly with the Express framework, allowing you to render pages directly from the server using rest.render. So that is why, rather than hard coding HTML, we will use the EJS files. Okay, so it is very straightforward. It's just a uh, basic template code which will display our video grid. We are defining some of the parameters in this style tags, and if we look back to the server code. Okay, let me walk you through, guys, with the server.js code. We will be importing all of our libraries here. So we will need Express library, which will be a framework for creating a server, and then we will be needing HTTP server that is going to integrate with Express. This is needed to use socket.io. We will need socket.io as well to enable the real-time communication. UUID. We will need to generate a unique identifier for each room. We will need EJS templates, embedded JavaScripts for rendering dynamic HTML pages. So once we have done all of that, we are going to define our routes. And then just make sure you configure your server to configure your server to serve the static files from public directory. In our case, it is script.js. But if it is a bit more complicated code, you need to add a couple of more static files, right? So just make sure you do that, and after that you need to define the home route, which will be redirecting users to the unique room when they visit the root URL. So what it is going to do, every time we will open the window, every time we will go to the root URL, it is going to generate a unique room so that the conflicts doesn't occur in the room creation. Okay, and then after that we need to create this uh, room route, which will be a dynamic route, and that is going to match any URL with a room parameter. It is going to render the room.ejs templates, as you can see, and it is going to pass the room ID as the data room ID. So as you can see, it is passing the room ID into the room.ejs, and after that the room.ejs template is going to be loaded into that web page. Okay, and after that we need to handle the real-time events between clients using socket.io. We will be using io.on connection. This is going to trigger whenever a client connects to the new server. Sorry, not a new server. Whenever new client connects to a server, and then this event is emitted by the client when a user joins a room. Okay, whenever the user joins the room, this is going to trigger it, and we will be notified as well that okay, the user has joined the room. Okay, and once everything is done, we just need to start the server. Okay, so this was all of our code. I know it looks a little bit complicated in the beginning because it has all the fancy and complicated stuff regarding the networks included in this. But if you will have a look at the code for 3 or 4 times, if you try to understand how each and everything is working, do not worry about the syntax. I get it, it's very complicated, but if you understand how this is working, if you basically understand how the workflow is going about his business, how the workflow is going about its business, you will be easily able to implement it in your applications without much hesitation. So our code is done. Let's try to run it. So first of all, we need to make sure that we start our peer.js server so that it can configure the connection between two users. So in this case, I'm just going to write it. I'm just going to turn it on with the port 3001, and in our other tab, a. I'm going to run our server. Okay, so it is saying that view and then set successfully. Server is running on the port 4000. Let me try to open it in my browser and I will bring it to the screen here. Okay, so as you can see, um, I have the video created here. Okay, now if you notice, this is the room parameter. Okay, so right now I am connected to a room as a user A. This is the room ID. Now, what I need to do, if I'll open the other tab, it is going to create a user B. That means another user has been created. Okay, but if we look at the dynamics of our code, it is going to generate the different room for the different user if we open it into the other tab. So what are we going to do? We will just copy this URL so that we can check. We will just copy this URL so that we can check if the connection is occurring between the users or not. So this means it is going to connect as a user B in the same room. So that means right now there are two users in the room. So, and if you notice, you will be able to hear the voice from the individual streams. So this means that inside this room, A36, whatever the string is, inside this room, two users are present. If we want to invite one more user, let's copy this URL and open it into the other tab. So what it is going to do, it is going to create a user C or one more user, and it is going to add that user. Okay. So let's do it one more time. If I, so now if you can see, three users are present inside this room. Okay. So look, this is how it works in terms of the functionality. So as you have noticed, we were able to create all the users, and we were also able to communicate among those three users. You can create the similar kind of functionality in your application. I would suggest you to start building this from scratch. First of all, your goal in the beginning should be to create this video streaming functionality, like the backend functionality, in a way that you will be able to communicate with each other as different users. Once you do that, you can customize your websites according to your needs. For example, I have a website where I have created everything. Like I have created the authentication functionalities, I have created rooms, I have created the friend request functionalities. Like for example, if I am a friend of someone, of a user X, then only I'll be able to call them, then only I'll be able to do the live streaming with them. So you can implement all of these things, but initially your first goal should be to learn how the WebRTC works. And it is also very important to understand each and every aspect of WebRTC, because if you want to make your application secure, you need to have the understanding of how this servers work. So that was everything from this video. Thank you so much for watching. And if you like this video, just do not forget to hit the like button and subscribe the channel. Thank you so much for watching.